Hey, Year 9, I'm showing you how to do waves on a string in case that you are having difficulty or if you're actually just not able to use the application. So this is the instructions, and the first thing, there's two activities, and I said to do how big are those waves. I'll do a separate video going through the answers to that. Let's focus on waves on a string. So when you click, if you remember, you need to click on it, you need to open up in a new window, and then you'll be able to edit the copy. Now, if I write on this one, it's going to be changing the one that you see. So I'm actually going to open with Google Docs, but then I'm going to save it as a copy. So make a copy, and I'll say answers. Whoops. Okay, so while that's opening up, the activity is working on something called this simulation. So if I click on the link and I click on it like that, I can open it up. I'm going to put it, if I drag it out, it's going to be a separate window. And if I push Alt-Tab, I can flip between the two. Okay, so that's the background. Sorry, actually, I realized the background is answering some questions. If you're not sure what they are, don't stress. I'll go through these answers. So our instructions here, it says we open the link. So we've done that. We should go to play. So we can just use it on the screen. We don't need to download anything. Now, it uses a piece of software called Flash. And what you need to do is if you come up, if I'm in Chrome, so if you're in something different, it might be a different sort of setup. But next to the URL, which is our web address, if I click on site information, you'll notice that I've gone to Flash. I've said allow. I go here, allow Flash, and now it will know to start. So I'm going to reload it. I mean, you could already see it before, but if you're having difficulty, that's what you need to do. Okay, so the instructions, just to show you, it said to zoom. Where's the zoom? There we go. Let's do 125. Okay, it says to select oscillate. So let's do that. What that means is it just makes it go up and down. And it's going pretty fast, but the thing is you can pause it and you can put it in slow motion. Okay, so just so you know that, it looks crazy then. And it selects the loose end on the top right-hand side. Okay, so this just means there's no, it's not going to, if you hold two ends of the rope, the person on the other end, there's going to be some back flow of the energy, so it kind of bounces back a bit. So it's kind of avoiding that happening. So if I watch it, you'll see it's going up and down. Okay, perfect. And all right, the next thing, so you should be able to see that. You'll notice my waves look very small compared to this one. It's because I think I turned my dampening down a bit. Okay, so things like that, just you can play around and see how they all work. Okay, then you need to select the ruler from the bottom right-hand side. You can see that there, and place it on the yellow dotted line. Pause the simulation and measure the wavelength of the wave. So let's show you how to do that. So let's go to ruler. Let's bring this ruler. Both these rulers you can turn around. So I'll just put it where the green one is, there. Bit across. Okay. And I'm going to pause it in a minute. Pause. Now with this pause, I noticed I didn't have it straight on the line. I can actually speed it through and stop it when the green dot's on the line. This is the easy way. There's a few ways you can measure wavelength, but let's start it here. Okay, so from here to here, that's half the wave. A wave is from the middle line. So this line here where the yellow dot is, that's kind of like if I wasn't moving the rope, that's its original position. And so the rope is being moved up and it's being moved down. And so it's being moved away from its position one direction, then back the other direction, the same amount, and then back to the middle. So that's what we call one cycle of the wave, going from here, down, up, and back to its starting point again. So that's what I want you to remember, because when we're talking about cycles per second, We're actually talking about how many of these are going through in a certain time period. We're not doing that right this moment. What we're doing now is just measuring wavelength. We can also use this ruler and measure amplitude, but I'll do that in a little bit. So if we look at this, we will be able to see, so from this point, that's 0. So half the wave is at 2.1, because that's 2.2, 3, 2, 4, 6, 8, 10. So 2.1. And so the full wave is at 4.2. Okay, so then I'm just going to come back here a bit. And I'm going to come down and fill in the wavelengths table. Okay, so the thing it says frequency here, like I don't know how to find frequency. You don't need to. So the amplitude is here already. We're not changing that right now. The frequency is here, and it says 1.50 hertz. So we are literally just reading it there, 1.50. I don't need to write HZ because it's already at the top of the column here. Okay, so we've got that. I'm just going to move it in a bit. Okay, and our wavelength, and what did I say it was? I said it's 4.2 centimeters, so 4.2. Okay, that's the first one. So the second one is to change the frequency, and I don't care which way you go. So we can go up and let's do 2. Sometimes nice round numbers help. You don't have to, but there you go. Let's say frequency is 2. Let's have a look at what happens here. So part of this is just to notice what the shape of the wave does and how it does things different. Okay. Just take a sec to get it back to the starting point. Okay, so here we can see the wavelength. So starting from 0, half of it is at like 1 point, that's like 8, so 1.7. The full one is at 3.245. So it's 3.5. So I would write at 2, my wave is at 3.5. Now, if your values for wavelengths are different to mine, that's probably because I've played around with dampening and forgot to tell you about that. Don't worry about it. It's fine, because really what I want you to gain here is an understand the relationship is still going to be the same, even if your numbers are a bit different. You'll notice that I've made the frequency a larger number, so it's gone up, and you'll notice what's happened to my wavelength. It's gone down. That's what I want you to notice when you fill in the rest of this table. And I want you to notice then what happens to the length of the wave and be able to put that in words. When I increase the frequency, how's the length of the wave changing? When I slow down the frequency, so the amount of cycles in the period of time, what happens to the wavelength again? Okay, so how long between the start and finish point of the wave? Something else about wavelength is you can actually measure from here. You can measure from this point to the same point over here. Okay, that's also wavelength, so that's from crest to crest. You could also measure it from trough to trough, but I just find measuring it along the middle is a lot easier in this case. Okay, so hopefully you guys are going to be able to do that, or at least you've got the first 2 values and a bit of an idea what's going on here. Remember, if you don't understand everything, that's not the end of the world. It's something that we can continue to work through and learn in this topic. All right, remember to ask questions if you need help. There's no problem with that. Anytime as well if you're not watching this in class time. Okay, bye guys.